Hi, welcome back. In today's video, we're going to talk about secants, tangents, and angle measures. Now, we've spoken about tangents in our last video, so if you haven't watched that video, go ahead and make sure you watch that one first. A tangent, as a way to review, a tangent is when a line intersects a circle at exactly one point. Secant, here's a new word for today. A secant is when the line intersects a circle at 2 points. Given that we're dealing with a line will never intersect the circle more than 2 points. It can cross it once or it can cross it twice. Now, the focus of today's lesson is we're going to be focusing on how to find the measure of an angle, given the intersection of secants, tangents, or both, one of each. So, this first theorem talks about what happens when two secants intersect inside the circle. Now, this is also under the assumption, I'm going to draw a circle here on the left. As a way to review, if we have a central angle, the angle in the center matches the intercepted arc. So this is AB. The measure of AB is equal to whatever x is. This arc measures the same because it's coming from the center. So now here we have two secant lines that are intersecting, and as you can see, these secant lines are going to intersect anywhere in the circle, not in the center. So they will not intersect in the center of the circle. When this happens, what we're going to be doing is, if you can see the color codedness, angle R, so the red angle, AB, this arc, and this arc are related in the sense that they both measure something, right? Whatever the measure of arc AB is, I'm going to put this in red, whatever this is, and whatever the measure of arc DC is, angle 1 will be somewhere in there, somewhere between these two measures, right? So to find the exact value, we're going to take the average of these two angles. So to find the measure of angle 1, we're going to take the measure of angle AB and we're going to add it to the measure of angle DC. And when we take the average by dividing it by 2, we get the measure on the inside. This could be located anywhere on the picture. As long as two secants are intersecting inside, right? Here's an example. As long as they're intersecting somewhere inside the measure of this arc and the measure of this arc, when we take the average, we'll find the value on the inside. As you can see by the one colored in blue, we'll call this one AD, the measure of this arc, and the measure of this arc. The measure of arc AD and the measure of arc BC. When we average those, we'll get the measure on the inside. Those two angles are vertical angles, so they're always going to be congruent. So we add them and divide it by 2. So to find the measure of angle 2, I can make another equation. We can take the average of the measure of arc AD plus the measure of arc BC divided by 2. So let's try an example. We're going to find the value of angle 4 and the value of x here in this next scenario. Angle RU, the measure of arc RU and ST, those are connected to angle 4. Right? Here we have vertical angles, so these angles are always going to be congruent. They're going to be on opposite sides of each other. So here we have an equation. The measure of arc RU plus the measure of arc ST, when we divide it by 2, that's going to give us the measure of angle 4. So we have 92 degrees plus 51 degrees divided by 2. If you put that in your calculator, that should give us 71.5 degrees. So the measure of angle 4 is 71.5 degrees. And because these are vertical angles, both of those sides are going to be 71.5 degrees. Now notice how adjacent to it, we have angle x. These two still form a line, right? So if this angle is 71.5 degrees, right adjacent to it, to find angle x, we can say angle x plus 71.5 should equal 180. They still form a line, right? So we subtract both sides by 71.5, and x should equal 108.5 degrees. Now, this is going to be 108.5 degrees, and vertical to it is also 108.5 degrees. Vertical angles are always congruent. So this is what we do when the secants intersect somewhere inside the circle. What happens if the secant and a tangent intersect on the circle? We spoke about inscribed angles in 10.4, and we said that whenever an angle is inscribed, I'm going to draw a picture so you can see it. Whenever we have an angle that is inscribed, meaning it lands on the circle, the angle will always be doubled to find the measure of this arc. It's always doubled. Well, that's similar here. As you can see, angle A lands on the circle. So whatever this measure is, we can divide it by 2 to get angle 1. Or if we have angle 1, we can multiply it by 2. Right? I'm going to put this one in red. The measure of angle 1 let's see. 2 times the measure of angle 1 should equal the measure of arc AB. Similarly, on the other side, I have angle 2. Angle 2 opens up to the right side, which means that if I multiply angle 2 times 2, I should get this other component, BCA. So 2 times measure of angle 2 should give me the measure of the other arc, BCA. Since angle 1 and angle 2 form a straight line, angle 1 plus angle 2 should also add up to 180 degrees because they form a line, this part being the tangent, and this one being the secant. So let's look at these examples, right? We have 2 examples looking at the same scenario or similar scenario. As you can see, we're trying to find the measure of arc JLK. JLK starts here and it opens up in this direction. We want to know what is the degree measure of that. Well, we already have 116 as this portion. This angle is already 116. So if I multiply this value times 2, I get the measure of that arc. 116 times 2, and that's just going to be 232 degrees for the measure of JLK. Now, if I wanted to find the other component, you can just take this answer and subtract it from 360, and we get whatever's left over. Or alternatively, since this part is 116, we know that adjacent to it, because this is still a linear pair, we can do 180 minus 116, which implies that this angle is 64. And then we can just multiply that angle times 2, and we would find the measure of this overall arc. The next scenario, measure of angle DEF. DEF starts here, and it goes all the way around to this component. The letters tell you the direction in which you're measuring. So we want to measure that side. Since this is 64, we can do this two routes. We can multiply 64 times 2, and that'll give us this degree. 64 times 2, and it measures this part of the circle. So 64 times 2 is 128 degrees. Since the circle is 360, we can say 360, take away 128, and that's going to give us the measure of DEF. And that's about 232 degrees. Alternatively, if you wanted, we could really extend this line and find this angle. Together they form a linear pair, so we know 180 minus 64 is 116 degrees. And then we can just double it, and you would see how we would also get 232. So it doesn't really matter on which route you want to go. Do you want to focus on the fact they make a linear pair, you subtract it from 180, and then double it? Or do you want to double it and then subtract whatever's left over from the circle, which is 360 degrees total? So far we've spoken about what happens when the lines intersect inside the circle, on the circle. Now let's talk about what happens when they intersect anywhere on the outside. When secants intersect on the outside, we have several combinations. We can have, as you can see in our first scenario, we can have two secants. In the middle, we can have a tangent and a secant. Here we have secants because we cross this twice. So these two lines are secants. Here we have a secant because it crosses twice and a tangent. Or we can have two tangents. Since we're trying to find the degrees and it measures on the outside, now we're going to find the difference between the arcs. This bigger arc, I'll put this one in red, sorry. This bigger arc minus the smaller arc will give us the measure of the angle on the outside. So we have angle A, measure of angle A will always equal the bigger arc, measure of DE, minus the smaller arc, measure of BC, and when we divide it by 2, we should get the angle on the outside. And that doesn't really matter what type of scenario we have. This is going to be the bigger arc in front on the outside, minus the small arc. And then we get the angle on the outside, angle A. So let's try an example. To find angle L is located on the outside. We're going to take the big arc, which is the one in red that you can see here. We're going to take that measure. Now we already know the other part of the circle is 102. So to find the measure in red, HJK, we need to take 360 degrees minus 102. So this measures 258 on the outside. Now that I have two values, I can create my equation and solve. I take the big arc, 258, minus the small arc, 102, and when we divide it by 2, it gives us the measure on the outside. So a little bit of basic math in the calculator. 258 minus 102 is 156. When we divide that by 2, we get 78 degrees. If you look at this other scenario, we have measure of arc CD. We're now trying to find the measure from here to here. I'm not able to simply subtract 95, as you can see here. We can't just subtract 95 from 360 because 95 is not the whole rest of the circle. We still have this component that we have nothing to know about. If we had all that information, we can just subtract it from 360, but we really don't. We don't know from B to D. So the equation still is what follows. We have the big arc minus the small arc divided by 2 will give us the angle on the outside. So measure of angle A is still going to equal the big arc, measure of CT, minus a small arc, measure of BC, divided by 2. Big minus small divided by 2 equals the angle on the outside. And I plug in what I have. The angle on the outside is already 56 degrees. The big arc, we don't know. We can just label that as x if you want. The small arc is 95 degrees. Whatever we have minus 95 divided by 2 should give us 56. Once I set up my equation, I really just have to solve for x. So let's get rid of the divided by 2 by multiplying both sides by 2. 2 times 56 is 112. And now I can solve for x by moving the 95 over. X equals 112 plus 95. So 207 degrees. I can plug that in here, and you can check. Is 207 minus 95 divided by 2 equal to 56? And the answer is yes. So let's review a little bit. We had 3 real scenarios. The 2 lines can intersect somewhere inside the circle. When that happens, we take the angle on the outside, we add them, and we divide it by 2. Because the angle on the inside has to be somewhere between the 2 values. If it's exactly in the middle and the center, it'll be the average of the 2. It'll be exactly in the middle, the midpoint. But when you average these 2 numbers, it'll find the location that measures exactly angle 1. When it lands on the circle, the angle will always be half of the intercepted arc. So as long as we know some information, we can multiply it times 2 or divide it by 2. Right? So 2 times the measure of angle 1 equals x. Or you can take x and divide it by 2 to get the measure of angle 1, depending on how you want to think about it. The angle on the lines will always be the smaller one, and the one on the arc will be the larger one. And then lastly, if the lines intersect outside of the circle, we're going to subtract the numbers instead of adding them. So we're going to take x degrees minus y degrees divided by 2, and that's going to be the measure on the outside. The biggest component here that we want to make sure we account for is the measure of the big arc minus the measure of the small arc. All of it divided by 2 equals the angle on the outside. So we have 3 scenarios. They can intersect inside the circle, on the circle, or outside the circle. And in this process, remember, we're still trying to find the measure of an angle. We're looking for degrees for all of these notations. So let's try some practice. As always, I'd like to give you some practice that you can try out. Feel free to pause the video. Try solving this yourself. I'm only going to set up the equation. I'm not going to go ahead and solve it, but I'm going to show you how to set it up so that you can solve it yourself. We're looking for this first scenario, the measure of RQ. RQ is this angle. I'm going to label this as x. I have 2 angles on the outside. Since the lines, the secants, intersect somewhere inside the circle, I know that the average of the numbers, if I add them up, divided by 2, I should get the angle on the inside. And then I just solve for x, right? Multiply both sides by 2, subtract 74, and you get your scenario. You should be able to get to 54 times 2 is 108, subtract 74, and the angle should be 34 degrees. GJF. GJF is this component. 2 ways of approaching this. This is still a linear pair. So I can form this in a straight line. I know 82 plus something should give me 180. So 180 minus 82 is 98 degrees. That's this little piece. Once I have that, multiply it by 2. That's really the rules of an inscribed angle, right? When the angle when an angle lands on the circle, that angle is going to be multiplied by 2 to find out the angle of the intercepted arc. 98 times 2 is going to give us 196 degrees. So from here to here is 196 degrees. Lastly, we notice that angle R lands on the outside, so I take the measure of the big arc minus the measure of the small arc, divided by 2, and it gives me the measure on the outside. The big arc is 103 degrees. The small arc is 43. When I divide that by 2, I should get the measure of angle R. So 103 degrees minus 43 is 60. 60 divided by 2 is 30 degrees. Okay, guys, I hope this has helped. Please let us know if you have any questions. Don't forget to like and subscribe if you haven't already. And as always, we'll calculate later.